Okay, so let us start the session. Actually, today's topic is alcohol, phenols, and ethers. Background noise. One second. Hello. Background. What? Again? Okay. So shall we start? Okay. One second. Wait. Okay. So alcohols, when hydrogen is removed by OH group, it is hydroxyl group, then we get alcohol. And alcohols are actually hydroxyl derivatives of hydrocarbons, in which one or more hydrogens are replaced by corresponding number of hydroxyl groups, like methyl alcohol, ethyl alcohol. So to find out the possible number of alkyl alcohols, the formula is 2 raised to power n minus 1, and possible number of alkyl alcohols and ethers plus ether, it is 2 raised to power n minus 1 minus 1, and possible isomers of ethers, that is 2 raised to power n minus 1 in minus 2 raised to power n minus 2. And is number of carbon atoms. Just apply this formula and let me know if there is any discrepancy. Okay. What is the IUPAC name of this compound? 2-methyl propane 2-1. And what is the IUPAC name of this particular compound? Yes. Just check once again. Yes. So possible isomer 2 raised to power n minus 2. Now, functional group, if we see structure of methanol, so it is like this, and phenol, say in methanol, angle is 108.9 degree, and in phenol, angle is 109 degree, and in ether, it is 111.7 degree. So, in case of ether, the angle is greater than tetrahedral because of the presence of steric hindrance between the alkyl groups, and other angles are less than tetrahedral because of the repulsion due to lone pairs. Now, bond angle in alcohol is slightly less than tetrahedral, and due to the repulsion of unshared electron pair of oxygen. And carboxyl bond length in phenol is slightly less than in alcohols, because in phenol, there is resonance, so CO bond has double bond character, right? So there is partial double bond character, and sp2 hybridized carbon is attached to OH group of the phenol. Now, order of bond angle is alcohol में सबसे कम होगा, then phenol and then ether. So because of those alkyl groups around oxygen, in ether bond angle is maximum, more than tetrahedral. And order of bond length, alcohol and ether almost same, and that is greater than in phenol. If we look at the uses of phenol, it is industrial solvent, can be used as a drying agent, dry cleaning purpose, preparation of perfumes, and as an antifreeze, both can be used as antifreeze, right? Alcohols as well as once. Yes. Once. Yes. To, am I audible? Okay. To prepare chloromethane, dimethyl sulfate, and formaldehyde, it can be used. Ethanol, again, it is used for dyes, oils, perfumes, even cosmetics, drugs, and mixture of 10 to 20% ethanol with petrol is used as motor fuel. Nowadays, you can see petrol pump pe aap jaoge, you will see there is written as ethan, means it, something is written like 10% ethanol is mixed nowadays in petrol. It can be used as an alcoholic beverage. Even आप वो जो पेट्रोल पंप है ना, आंध्रा में कौन सा है, बिसल पेट्रोल पंप, you can see it is written 10% alcohol is mixed. It is used to prepare chloroform, iodoform, acetic acid. What is the formula of iodoform? So rectified spirit is 95.6% ethyl alcohol and 4.4% water. And that is an azeotropic mixture. What is azeotropic mixture? Yes. Yes. Power alcohol is 20% absolute alcohol and 80% petrol. Absolute alcohol is ethyl alcohol containing less than 1% water. And to the maximum 1% water, it is 99% pure. So one is used as antifreeze, ethanol. Oh, by mistake, it is 95.6% ethyl alcohol, 4.4% water is power alcohol is 20%. Yes, it is rectified spirit. And absolute alcohol is 99% or almost pure alcohol. And power alcohol is 20% alcohol, ethanol, and 80% petrol. More CO bond length of CO is observed in ether. Written alcohol. Just look at it. Do you have NCERT? Just check. Here value is these are the values. Okay. So what is the CO bond length in alcohol? Okay. So that means ether. So what will be the answer? Say what are the value? This is 142. Here it is 136. And here 140. 141. So that means 141, 136, and 142. That's why alcohol is the right option. इथेनॉल और मिथेनॉल में से मिथेनॉल CO bond length of CO. Okay, and then ether. Okay, that means right option, right? Bond length of CO in phenol is slightly less than CO of methanol because of partial double bond effect. So first is preparation of alcohol. First is hydration of alkenes. That is hydroboration, oxidation of alkenes. That is very important. Then reduction or hydrogenation of carbonyl compounds and preparation from Grignard reagents. Now first is hydration of alkenes. That is commercial or industrial preparation. So alkene is addition of water. So H is added on one side and OH on the other side. So this is ethyl. This is concentrated H2SO4. In cold, what happened? H plus sign attack on one carbon because it is symmetrical alkene. So we get ethyl hydrogen sulfate at 383 Kelvin around. But if we heat it, then this OSO3H group is replaced by OH. So we get ethanol and H2SO4. So this is called acid catalyzed hydration of alkene, where H2SO4 first used is removed, at the end it is recovered. So we get primary alcohol, and this is commonly called as grain alcohol. Mechanism of hydration of alkenes. First is protonation of alkene to form that carbocation. See, water in the presence of acid give H3O plus. Now this H3O plus that will accept one H plus ion, and we get carbocation along with water. And after getting this carbocation, now water will attack on this carbon, and water acts as a nucleophile. So this nucleophile will attack on water, and we get protonated alcohol. This is protonated alcohol. And then in step 3, there is deprotonation to form an alcohol. So एक बात नोटिस की आपने कि this one step जो है, it is reversible in it. Reactant step is this one actually, because here there is breaking of two bonds. Yes, formation of carbocation. Then deprotonation, and we get alcohol. If we have propene now, see, propene is unsymmetrical alcohol. So in this unsymmetrical alcohol, if this H plus and OSO3H negative attacks, you know, first of all, we apply Markovnikov's rule. So what is Markovnikov's rule? Yes, hydrogen will go to the negative part is attached to that carbon which has lesser number of hydrogens, or hydrogen H plus is attached to that carbon which has more number of hydrogens. Means rich becomes richer. डबल बॉन्ड के अक्रॉस जिस कार्बन पे ज्यादा हाइड्रोजन होंगे उसमें और ज्यादा हो जाएंगे. So we can call it as rich becomes richer. So we get iso or secondary propyl hydrogen sulfate. When we heat it with water, obviously we get alcohol. That is iso or secondary propyl alcohol or propane 2O. Tell me, if we have isobutylene, what is the product form? Two methyl. Yes, yes. Two methyl propane 2O. One second. Two methyl propane 2O. ओके, अभी आवाज में कोई डिफरेंस लग रहा है? मीन्स जो पहले से अलग लग रही है आवाज से सेम ही है। अभी थोड़ी क्लियर है या पहले से? अच्छा, आज प्रॉब्लम अभी भी है ना? ऐसा तो मैं फिक्स तो करता हूँ, पता नहीं क्या प्रॉब्लम है। ओके, ठीक है, तो कंटिन्यू करेगा। ओके, so isobutylene, obviously in the presence it is acid catalyzed hydration of alkene. So obviously we apply Markov-Nikov rule. So there is a formation of tertiary butyl alcohol, or we can say 2-methyl propane 2-ol. So tertiary alcohol is formed. So this method is used to prepare secondary and tertiary alcohols. Commercially important alcohols are methanol and ethanol. Methanol is also known as wood spirit. That's also important. It is known as wood spirit because it was produced by destructive distillation of wood. CO plus H2 is known as mixture of CO and H2. Mixture of CO and H2. That is known as, that is called water gas. And CO plus N2, that is called producer gas. And yes, both are fuels. And water gas and producer gas, out of these two, water gas is better fuel. Because in water gas there is CO and H2, both are fuels. But in CO and N2, only CO is acting as a fuel. That's why water gas is a better fuel than producer gas. Methanol, you know, it is poisonous. Ethanol, it is obtained commercially by fermentation. Invertase enzyme is used to convert sucrose into glucose and fructose. And this glucose, what? Sorry. Yes. And glucose, that is converted into ethyl alcohol and carbon dioxide in the presence of xylase. And the ethanol is a colorless liquid. Its boiling point is 351 Kelvin. hydrolysis of 1-bromopentane by an aqueous NaOH gives 1-pentanol. Hydration of ethene produces yes, ethanol. Hydration of 2-methyl but 2E. Two methyl, yes, 2-methyl butane 2-ol. Hydrogenation oxidation of alkenes. So in hydrogenation oxidation, first we have propene, we treat it with B2S6, so we get tripropyl borane. This tripropyl borane then treated with H2O2 in the presence of OH negative, and we get propane 1-ol. This it seems to be anti-Markovnikov addition of water. So this gives anti-Markovnikov. Action gives anti-Markovnikov's product. Yes. The only primary alcohol that can be prepared by hydration of alkene is yes, because in other cases we get secondary or tertiary alcohols only. Hydrogenation reaction follows isobutylene on hydration in the but say there is no violation of anti-Markovnikov rule, but it seems like anti-Markovnikov addition of what? Isobutylene on hydration in the presence of 50% H2SO4 gives CH3. Yes. Ajay? So what is normal butyl alcohol, isobutyl alcohol, tertiary butyl alcohol? It will be isobutyl means primary alcohol. आइसोब्यूटेन के एंड वाले कार्बन पे OH लगा दो, बट OH कहाँ लग रहा है, कौन सा कार्बन है, प्राइमरी है, सेकेंडरी है, टर्शरी है? We have isobutyl. It is, okay, wait. We have CH3, CH3, CH2. This is isobutyl, right? This is isobutylene. Because okay, say this is isobutylene, right? So isobutylene means double bond. कहीं भी लगा दो इसमें, ठीक है? So we get CH3, CH3, CH3OH, right? So it is tertiary butyl alcohol. Okay? मैं आपको थोड़ा सा बता देता हूँ एक बार. See, this is butane. So in butane, there are two types of alcohols. This is normal butane. Primary alcohol, sorry, primary, there are two types of hydrogens, primary and secondary. So if we remove primary hydrogen, we get normal butane. Normal butane का primary hydrogen निकाला, normal butane. Secondary hydrogen निकाला, we get secondary butane. This is isobutane, right? In isobutane, there are primary hydrogens and so if we remove primary hydrogen, we get isobutane. Isobutane, isobutane. If we remove tertiary, yes, there are only four alkyl groups. From normal butane, we get normal butyl and secondary butyl. From isobutane, we get isobutyl and tertiary butyl. Okay. Okay. Now next is reduction Oh. So first is it is methods of preparation of glucose में reduction of carbonyl compounds. So it is either catalytic hydrogenation or using nascent hydrogens CO to give CHOH. It is formaldehyde. So if we treat it with H2 nickel, we get alcohol, methanol. If we have acetaldehyde, we get again alcohol, that is ethanol. In ketone, we get secondary alcohol, that is isopropyl alcohol or secondary propyl alcohol or propane 2-ol. Now, formaldehyde with sodium amalgam H2O, sodium borohydride or lithium aluminum hydride, there is formation of primary alcohol. In all the cases, you can see we get the same products. So aldehyde give primary alcohol, ketones they give secondary alcohol, and tertiary alcohol we cannot prepare by this method. Yes, and actually, if we reduce primary aldehyde, because there is addition of hydrogens only. So to prepare tertiary alcohol, what we have, we should have 3 alkyl groups on the carbon attached to OH. So ketone, there are only 2 reacted, aldehyde and ketone. Aldehyde has 1 alkyl group attached to CO. So it will always give primary alcohol. Ketone, this one. In aldehyde case, we have primary alcohol only. Whatever aldehyde may we have, we get always primary alcohol. Ketone always give secondary alcohol. So tertiary alcohol, there is no question of tertiary alcohol. Formation of tertiary alcohol can take place. जो आप बोल रहे हो, that is when we oxidize alcohols. Yes, when we oxidize the products, when oxidation takes place. Yes, tertiary alcohol we can prepare by regeneration, but in this method we cannot prepare. And lithium aluminum hydride, it is an expensive reagent, so we use for special purposes only, and at the same time it is very violent. It can react with water. But acetic acid, we cannot reduce it with sodium borohydride. So we have to use strong reducing agent like lithium aluminum hydride. Or otherwise we will convert it into first ester, and then by using the same, or we can use H2 nickel, H2 palladium to convert ester into alcohols. No, reaction is very slow. Yes. Now cyclohexanone, sorry. So we get cyclohexanone, and if we oxidize cyclohexanone, we get cyclohexanone. reagent used for converting ethanoic acid to ethanol. Yes, it is LiAlH4. Esterification of carboxylic acid followed by reduction with lithium aluminum hydride. Now, Grignard reagent. So if we use Grignard reagent, first step is addition of R and MgX. So in the presence of dry ether, R dash is attached to carbon, R double dash, and OMgX. And then this complex is hydrolyzed, and we get alcohol. So obviously, if it is aldehyde, if it is formaldehyde, we get primary alcohol because then R and R dash both are H. If other aldehydes are there, so either R or R dash is hydrogen. This is alkyl only. So we get secondary alcohol, and if it is ketone, then we get tertiary alcohol. So formaldehyde is primary alcohol. Other aldehydes. Yes, we can. But then 2 moles of Grignard reagents are added up. Yes, aldehyde or ketone. So by Grignard reagent, we can't prepare methanol. That is its limitation. And we can't prepare any compound which contains only one carbon atom. Alcohols can be obtained from carbon compounds by reduction. Now, acetaldehyde on reduction gives yes. Secondary alcohol is obtained from reduction of yes. So by using Grignard reagent, we can't prepare identify the reagent to form tertiary butyl alcohol from acetone. Yes, Grignard reagent. When ethyl magnesium chloride is treated with formaldehyde, what will we get? Propane 1. Now, alcohols, lower members are colorless liquids, have higher members are solid. Lower members of alcohols are completely soluble in water, and solubility decrease with increase in their molecular weight because of the increase in the size of hydrophobic part, that is alkyl part. Alcohols have high boiling point, then corresponding alkanes, alkyl halides, aldehydes, ketones, ethers, because they are associated through intermolecular hydrogen bonding. There is intermolecular hydrogen bonding. and the boiling point increases with the increase in number of carbon atoms, or we can say with the increase in molecular mass. In branch chain alcohols, their boiling point is decreased because of the compact structure due to decrease in surface area, due to decrease in van der Waals forces. And alcohols are neutral to litmus. Alcohol are act as Bronsted acids as well as Lewis bases, and therefore they are reactive because Bronsted acid. Why? Because they can give H plus ion to active metals, and because of the presence of those lone pairs on it, they can donate lone pair. Therefore, they can act as Lewis bases. OH. Yes, there are few reactions. There is CO bond breaking, like in acidification. But in that reaction, even it act like no, in acidification there is a removal of OH group. Means H is removed. So there are reactions involving breaking of OH bond and reactions involving CO bond cleavage. So in case of OH bond cleavage, reactivity order is primary, secondary, and tertiary. Yes, because as the releasing group increases, that will increase electron density on the oxygen, and therefore OH bond breaking becomes difficult. But in case of CO bond cleavage, the activity order is tertiary, secondary, primary, because tertiary carbocation is more stable than secondary than primary. So action of metal, obviously it shows acidic nature of alcohol. With active metal, it can remove H plus ion. It can give H plus ion, and we get hydrogen gas. So electron releasing group decrease the acidic strength. So as number of releasing groups increases, acidic strength decreases. Electron withdrawing group increases the acidic strength. Electron releasing group decreases the acidic strength. Means electron releasing groups are inversely proportional to acid strength. Ethers do not have hydrogen bond, so they have boiling point similar to, almost similar to hydrocarbons, even sometimes less than hydrocarbons. Acidity of phenols. If we talk about the acidity of phenol, you know, phenols and phenoxide. If we draw their magnetic structures, then phenol, when we draw magnetic structure of phenol, there is separation of charge. But in phenoxide, there is delocalization of negative charge. And that's why phenoxide ion is more stable or more resonance stabilized than phenol. And this accounts for acidic nature of phenol. But in alkoxide ion, if you see, there is alkyl group which increase the electron density of oxygen, and therefore this alkoxide ion is destabilized. It is destabilized. So you see, delocalization of negative charge makes phenoxide more stable, and that favors the acidic nature of phenol. But in alkoxide, negative charge is localized on oxygen, and that's why in phenoxide charge is delocalized. There is delocalization complete. Now esterification, if you see alcohol and acid in the presence of concentrated H2SO4 C, that is important. H is removed from alcohol and OH is removed from acid, and we get ethyl acetate or ethanoate, you can say. Concentrated H2SO4 is acting as dehydrating agent, but if we use dilute H2SO4, reaction is reversed. That's why as water is formed and concentration of H2SO4 is decreasing, ultimately what happened? There is an equilibrium between the ethanol, acetic acid and ethyl acetate. Hydrolysis of ester is a reversible reaction. So you should keep in mind it is a reversible reaction. It has 3 steps. In first step, there is protonation of carbonyl group. We get this carbocation. Then nucleophilic attack of alcohol takes place on this carbon, positively charged carbon. This is protonated alcohol, and then there is a loss of water molecule. Proton is transferred, and say we get this carbocation, and ultimately ester formation takes place. So if we use this tracer technique, one is O18. So see, this O18 is in the ester. This one is important. If an esterification is carried out by using an alcohol containing radioactive isotopic oxygen O18, so that O18 is found in ester. That proves that hydrogen of alcohol and OH of acid is removed. Reactivity of alcohols towards reactions involving breaking of OH bond. Esterification is a reversible process. Ester is obtained when alcohol react with carboxylic acid. Alcohols when react with metals, it gives corresponding alkoxide and hydrogen gas is formed. Now, action of Lucas reagent. So when Lucas reagent is used, you know, लो खुश रह भाई क्या ना सुन तेरे क्लास वाला है तो 10-5 मिनट कर रहा हूँ okay. So there is the removal of water. So see, concentrated HCl and hydrogen Cl2 that give Lucas reagent, and this reaction is called Group's process. And this Lucas test for alcohols, you know, alkyl halides are partially soluble in water, and therefore there is turbidity. So tertiary alcohol give turbidity immediately. Secondary alcohol within 5 minutes, Primary alcohol do not produce turbidity at a room temperature. No, see, this is secondary alcohol. Tell me what is the product formed here. First of all, see, HI is an acid. So H plus ion will attack on. Yes, it gives protonated alcohol. What is removed? We get carbocation. Yes, yes, but two hydride shift takes place. So iodide will attach at tertiary. So we get tertiary pentyl iodide along with H2. So this is the mechanism. First of all, H plus ion form protonated alcohol. Then this protonated alcohol, water is removed. We get secondary carbocation, but इसके बगल में क्या है? Tertiary alcohol. So therefore, there is 1,2 hydride shift. Secondary alcohol, this 1,2 hydride shift takes place, and we get tertiary alcohol. And now, because it is more stable, that's why this shifting takes place. So iodide will attack it. So we get tertiary product. Yes. Oh, primary, secondary, tertiary alcohols are distinguished by oxidation method, because primary alcohol will give aldehyde or carboxylic acid. Secondary alcohol will give ketone and carboxylic acid with lesser number of carbon. Tertiary alcohol oxidize. It is difficult to oxidize, and if it oxidizes, we get ketone with lesser number of carbon, carboxylic acid still less number of carbon. Victor-Mears method. This is a. I will show you the slides. Actually, primary alcohol give nitrous. So N means C double bond NOH. Then this is long method. There is. I will show you this. This is a method to distinguish primary, secondary, and tertiary alcohol. Because first iodide is formed, then NO2 is attached. Okay, then ultimately it will react with HNO2, and we get different products. Which alcohol is most reactive towards HCl in the presence of tertiary? Lucas reagent is yes. Okay, we will leave it here only. Okay, tomorrow at the same time. Sure. Oh, bye. Bye. Okay. Good night.